All right, so question number 1, it says, which diagram best represents the magnetic field between two magnetic north poles? So, first of all, we know that like charges repel one another. So, it says two north poles, so there's going to be repulsion. So, this is attraction, and this is nothing. So now we're looking at B and C, okay? So again, also we know it goes out of north and into south. So the answer is going to be B. So we have to look at the arrows as well as attraction or repulsion. Number 2, which statement best describes the polarity of the magnetic poles A and B? So, first of all, we say it's going from A to B, okay? The fact that it's not like this is attraction, so we also know it's attraction. So we know that the poles are going to be different, meaning one's going to be south and one's going to be north. But then we see it's going out of A and into B, and it always goes out of north, just like in the question 1, and into south. So because we know it goes out of north and into south, we know the answer here is C. So A is north and B is south. Out of north into south. All right, number 3. That looks exactly like the lab that we did. When two ring magnets are placed on a pencil, magnet A remains suspended around magnet B. Which statement describes the gravitational force and the magnetic force acting on it? So again, we drew a free body diagram when we did our lab. And again, we had our weight going down and we had our magnetic force going up. So the gravitational force is attractive and the magnetic force is repulsive because we know that these two magnets are repelling one another. So the answer here is A. And we know that the gravitational force is acting down. So this is A. All right. Number 4. The diagram below represents a bar magnet. The direction of the magnetic field at P, okay, so remember it goes from north to south. So now that what we're going to do is we're going to kind of try and draw the line. So we did this in our other lab where we drew the magnetic field around a bar magnet. So remember it's going to go from north to south, north to south, north to south, and north to south. So at point P, it's going out of north and into south. So at point P in the middle, it's going like this. So it's going, which direction is it pointing? It's pointing towards C. Because here it's pointing to the right in this direction. So the answer to number 4 is C. Number 5. The field around a permanent magnet is caused by the electrons, because we've been learning this all along, that the electrons are the only thing that move. So the answer to number 5 is B. All right, number 6. Magnetic fields are produced by particles that are moving in charge. So number 6, the answer is A. All right, let's go to the next page. Okay, number 7. It says, which diagram best illustrates the magnetic field that exists around current carrying wires? All right. So this is right-hand rule number 1. So this thing here, pretend that's your pencil. Okay. Now, this is electrons. See, E are electrons. If they told us it was conventional current, we use our right hand. But because it's electrons, we're going to use our left hand. Okay? The thumb is going to go in the direction of the electron. So here's this. My thumb is going up. And which way are my fingers going? My fingers are wrapping around my pen this way. So that's why I know the answer is C. So again, that's right hand rule number 1, that your thumb is the direction. In this case, we're using our left hand because it's electrons. The thumb goes in the direction of the electron flow, and then the fingers are going to curl in the direction of the magnetic field. All right, number 8, electrons. So again, it's electrons are flowing in a conductor as shown in the diagram. What is the direction of the magnetic field? So here's my pen again, and I'm going to take my left hand and go this. So here, my fingers are pointing up. So if my hand is flat, the fingers are pointing up, and pointing up is coming out of the page, and then this side is going into the page. So this is into the page, and these are coming up. So again, we're going to use our left hand. The thumb's in the direction of the electrons, and the fingers curl in the direction of the magnetic field. So the answer to this one is over here by point P, they're coming out of the page. Remember, dots are like, it's like an arrow, a vector. So the dots are going up, and then just like this pen, see how it has an X? That's going into the page. So the answer here is D. And this was C. All right, number 9. In order to produce a magnetic field, an electric charge must be moving. All right, number 10. If the current through a solenoid increases, the magnetic field strength of the solenoid also increases. All right, number 11. The north pole of a magnet will be repelled by a north pole of another magnet, because we know that like poles repel one another and unlike poles attract. Number 12, like magnet poles always, that's what we just said in the last one, repel. Number 13, magnetic force, is it stronger near a pole, the magnet's pulled? Is it field force? Does it act at a distance? And we know that all of those are true. Number 14, magnetic fields exist. Do they exist near a magnet, farther from a magnet, within a magnet? All of those. Number 15, a compass needle naturally points towards the geographic North Pole, the South Pole of a magnet, Earth's North Magnetic Pole, and again, the answer here is D. Because remember when we learned about Earth and Earth's. All right, and that's the review, and that's it.